Hello, this is Mr. Collier, and today we're doing some more integration, of some different functions. Okay, so some of these things are pretty common sense. If the derivative of a constant is 0, so the integral of 0 is a constant. Derivative of a constant times x is k, so the integral of k is kx plus a constant, and so forth. If you have a constant times a function, you can bring that out in front of the integral. If you have a sum of two functions, you can integrate both of them and then add them together. Okay, and this is the power rule. If you got x to the power of something, you increase the exponent by 1, then you divide by that same exponent. So let's do a couple of examples. Some of these you've seen before. This is integral of 1 dx. So that means it's just going to be 1 times x, or just x plus c. This one here, you increase the exponent by 1, divide by 2, plus 2x, plus c is the answer to that one. Let's do sine x, because we know the derivative of sine is cosine. Or, actually, let's go backwards and say the derivative of cosine is negative sine. So when I integrate sine, you're going to get negative cosine. So it's going to be negative 4 cosine x plus c. Right? So you can check by always finding the derivative, right? If you get the derivative of cosine is negative sine times negative 4 gives you positive 4 sine. Let's look at this one. You just simply increase the exponent by 1 and then divide by that exponent. So that's the answer to that one. When you got something like this, you want to write it as a polynomial. So x divided by root x is root x. 1 divided by root x, well, it's 1 over root x. Let me write that as exponents. That's the integral of x to the power of half plus x to the power negative half. The dx, so this is the way the notation always works. You have the integral of this function with respect to x, so you always got a dx at the end to tell you what the variable is that you're differentiating with respect to. So I'll increase the exponent by 1. Increase that by 1, you get 3 over 2. Divide by 3 over 2 is the same as times 2 over 3. Then I'll increase this exponent by 1. X power of half divided by half gives you times 2, and then don't forget the plus c. Now remember, the derivative of etx is just etx, so we're going to do a couple of these. So this is the same, right? The integral is going to be exactly the same, except we have to divide by the derivative of the exponent, so we have to divide by negative 1, which is just negative 2e to the negative x plus c. Now, over here, we have to be very careful with this one. We cannot simply add 1 to the exponent here, because this is not a linear factor. Okay, the derivative of this is not constant, so you cannot just simply add 1 to this exponent. What we have to do here is you have to expand the brackets. So you have 1 minus 2e to the negative 3x plus e to the negative 6x is what you get when you expand. Then integrate each term. You have x. We're going to have the same thing, but we have to divide by negative 3. So you're going to have plus 2/3. This is going to be the same thing again, but we have to divide by negative 6. So it's going to be minus 1/6 e to the negative 6x plus c. Now the last one, be careful. This is a product of two functions, so you can't just add 1 to this exponent, and you can't integrate them separately. But notice that if you had e to the x squared, then the derivative is 2x e to the x. Okay, so if we had 2x e to the x, it'd be pretty easy. We can make this a 2 by writing it as 5 over 2 times the integral of 2x e to the x squared dx. So this answer is 5 over 2 times, because the derivative of this is this, the integral of this is this, so that's going to be times e to the x squared plus c. So be careful. You can't, if there's a product of two functions, you can't simply integrate both of them independently. If you've got a function, nonlinear function to the power of something, you can't just integrate it like a power rule. Okay, so we kind of talked about this last time. Yeah, this actually doesn't make sense, so I have to delete that. But I should probably say x is not equal to 0. Anyway, integral of 1 over x equals ln absolute value of x plus c. So over here, when you integrate, you're going to get 2 ln 2x plus 5 absolute value of that. But by chain rule, you're going to multiply by an extra half. Okay. Plus c, so the halves cancel. You have ln 2x plus 5 plus c. Okay, over here, you've got 3 times ln absolute value of 5 plus 6x. Then you're going to multiply by 1 over 6, or just divide by 6. So that's actually half ln absolute value of this, and yeah, and then you can actually, no, that doesn't really help. I was going to say you can take the half and write this as square root of that, but that doesn't really simplify things. Okay, and we got some trig functions here now. And if you've got a linear factor, you can integrate this. But if you got something like cosine x squared, then you cannot integrate that. Okay, that is impossible. Unless there's some sort of trig identity you can use. Yeah, maybe there's some way, but I don't think you can do that one. Alright, so here we have integral of sine is, integral of cosine is sine, because the derivative of sine is cosine. So you're just going to get this, and you got to divide by 3 plus c. And remember, this is cosine x squared dx. Now this is a function squared, so you cannot simply add 1 to the exponent. So what do you do with that? This is a very important one, actually. So this one comes up a lot, actually, on IB exams. So you can't do it as it is, but you can use maybe an identity from your formula booklet. Now you got cosine squared here. You've also got a cosine squared here. So this one's the useful one because it's just cosine squared. So let me just take a screenshot of that. So let's use that now. You can rearrange it. So just this part, this equals this. This means that 2 cosine squared theta equals 1 plus cosine 2 theta, and you can divide by 2. Oops. So that's squared theta equals 1 plus cosine 2 theta over 2. So I can replace the cosine squared with that. So it's the same as the integral of half plus half cosine 2 theta d theta. Or x, sorry, it's x in this case. I don't know why there's an equal sign. Okay, so we have that. So when we integrate that, we can integrate half, this term and this term separately. So the integral of half is half x. And the integral of this is half times sine 2x. Okay, and don't forget chain rule. I've got to multiply by a half. Or I shouldn't call it chain rule, it's like reverse chain rule. So that checks out, right? Integral of sine is cosine. Yes, all that works out nicely. So this is just half x and plus a quarter sine 2x plus c.